Hey everybody, this is Larry. This is day 8 of the Advent of Code in 2024. We have a minute and 30 seconds to go. This is a Saturday to slash Sunday problem. I don't know how people call it. I guess it's technically a Sunday problem. But, and you know, my guess or my hope, I don't know, maybe a guess is that it gets a little bit harder. So we'll see. Because it generally tries to be a little bit harder on the weekends because, well, who needs sleep on weekends, right? So we'll see. But yeah, so far this year, haven't been doing so well in the leaderboards, but that's okay. We're having fun, and I feel like I'm finally warmed up a little bit with my fingers and my codes and all these things. So we'll see. 1 minute to go. So I'm going to move to my thing to my terminal. I'm ready to, get into it, and I'm excited. Yeah. Yeah, and remember everybody to have fun and to learn, and that's all that matters. And for me, mostly, I'm learning that I'm an idiot, but that's, you could learn different things. No, I'm just kidding. But now it's fun to do. I think one thing that I'm still it's kind of tough. I mean, because I'm still trying to figure out where I'm trying to go for that Christmas weekend, or like long weekend or whatever, so I don't know. So I don't know if I'm going to be able to finish the last at midnight anyway, at the starting time, but I'll definitely work on them. But so we'll see. So it gets close. I would like to finish on the leaderboard once. So yeah. All right, 5 seconds to go. No more chatting. Let's go. Focus. Okay. Oh jeez, I cannot highlight correctly. What? I don't have to read. Okay. What's an anti-node? Say what? Okay, well, I don't even understand this farm enough to get whatchamacallit. But what are these zeros? Are these O's or zeros? I'm not understanding it correctly or at all. Okay, so it's a digit. So is that in the input? Am I? And 10. I think I get it. I was just confused with this other input. I see. No, I'm not confused. It's just that. Okay, the explanation. Okay, fine. I think I get it, but I feel like I'm too slow. Okay, fine. Okay. I think I get it. I just had trouble understanding it. Oh well. Yeah, okay. What are you doing, Larry? Why am I so slow? Okay. Is it the other direction? Math is hard. So then, okay, so we have this. X is 1, 1, so then you want to add. Okay, fine. I think this is fine. It would go into the other direction later. 9 to 76. Okay, well, I mean, that's not right. Right? Oh, it has to check inbound. Okay. Then now. I forgot about the inbound thing. No, but then I'm undercounting, so that's not right. No, I'm undercounting, so that's not right. Well, I mean, we should need this anyway, but why is this wrong? Okay, YOLO, let's try it. 335, that's a little bit slow. I took too long reading. Okay. Exactly in line by these two. Say what? Okay, I have to update our model. Is what they say, right? Let's see. In line, the T are exactly in line with two antennas. Could at any grid position exactly in line with at least two antennas of the same frequency? We got. I don't know that I understand this one. Okay. Any equipment exactly in line with at least 2 antennas of the same frequency regardless of distance. Okay, I mean that's fine. Oh, I see. Okay, yeah. Okay, I mean that means I'm not finishing quickly. Is my point. It's the story. Or like I'm finishing quickly, but not finishing quickly enough is what I'm seeing out of this. Do you include the original things? Maybe not. Well, starting. I could probably write this in a cleaner way, but I am not going to. Oh, it's this slow, huh? It's either it's this slow or I have a typo somewhere. All right, let's run it, and then we open a new window and and then optimize for it. Oh, that's from, I don't know when that's from. Okay, so maybe there is hope if I have to optimize. No, it should at least do the test correctly, right? So something is very silly. Oh, this is silly. Silly, Larry. 29 is wrong. Dong dong dong. Oh, on every antenna. So I guess you also add. Then I guess maybe you could have done it this way. Oh well. I wasn't sure you're supposed to include the original antennas. 34. So 1, 2, 3, 3. 295. I mean, sounds about right. I mean, I wasn't that fast on this one today. I just had trouble reading, honestly, for a while, even on part 2. I mean, I feel like I'm respectable, but a little bit slow, just not reading it correctly. Like, I think on a good day, I probably, could have cut off a minute. I don't know what that means for the leaderboard, but 1 minute is outrageous. Yeah. So part 1, it finished at 4 minutes. So I wasn't that close, honestly. But I mean, I kind of knew that. I was just having a lot of trouble on the reading part today for whatever reason. And then part 2 is 7:12, so I didn't even finish part 1 when they finished. Yeah, I don't think that was a hard part if you got part 1 correctly. I took 4 minutes, which actually felt really long. I had some typos and just understanding about it as well. But I mean, overall, I don't know. Wish I had more of a buffer with actual getting in the leaderboard in the earlier days, because it's actually remarkably consistent for it, but consistently not on the leaderboard, which is not great. But yeah, all right, let's go over the code real quick. I don't think I do anything that crazy, honestly. For Q1, I mean, it's just all maths. Once you understand it, it's just about. I mean, I think the way that they phrased it is a little bit tricky, but as long as you make sure that your vectors and your dimensions are correct, it's fine. I think because because I think the way that they describe it, I'm just drawing it out, is that if you have 2 points, and this is, has some distance d or dx dy component, if you want to call it that, then now you want this point to go 2 times this to go here as a thingy, and then this point, maybe I'll change the color a bit. No, I like the symmetry. To go here as this point, right, with 2 times dx dy, maybe put that as a vector if you want to put it as a vector, right? So something like that, which is where it I think they mentioned the problem mentioned something like twice the distance. I got very confused on this part, honestly, but yeah, right. So basically, this is what the problem is asking, and you're trying to find unique places for these points, and yeah, I mean, I think that's pretty much it. And of course, if you kind of and I tried, maybe you didn't need to do this, honestly, but you can also see that in this case, then this distance, and let me change the color actually for this one, then this distance is just dx dy, and then as long as you kind of, I think the tricky part to for implementation is that it's very easy to kind of get the signs wrong, and if you get the signs wrong, maybe you go this way, maybe you go this way, maybe even go back to this way, right? So as long as you kind of make sure that your variable names and all these things are correct, it should be fine. So that's part 1, at least in terms of understanding. Let me show the code real quick. Yeah, and this is pretty much what it sounds like, right? Well, I guess the other thing is also kind of collect all the antennas together. So you don't want to do like a loop through the entire input. Well, maybe it's still fast enough. Eventually it will be fast enough, or will run to completion. But for each one, you want to just like have a list for that lookup. And then once you have that, this is what I have here. And then I just do for every 2 points, I do, start x, start y, nx, ny, and then with dx, dy as we described. And then I just do this to make sure that it's not at the same point, though I guess the way that I wrote it, it should not. But I thought about writing it as a number of different ways, so that's why I had this here. And then that's pretty much it. And then you just you could have also done the check here. Maybe if I wrote it in a cleaner way, then this is easier here or something. But either way is fine. Like, you're not going to get that many. If you have n squared points, you're going to have, or if you have n points, you're going to have n squared things. And, maybe that filters a little bit, but it's not a big issue. And then for part 2, it's kind of similar, except for then now, let me bring back the drawing. I mean, if you have part 1, I feel like part 2 should be pretty straightforward if you have thought about it in a consistent way. You just, okay, well, you have this dx dy, then just keep going and then keep going. I'm drawing off the board, maybe in the theme of the problem, and then just kind of keep going, right? And my code kind of reflects that. I don't think I do anything too crazy. I think the only thing that I change is just this chunk. Again, this part is not even necessary, I don't think. But here, I just have a while loop to make sure that it is kept in bound. Actually, I think I messed up here. I think this is actually wrong. Why did I write it this way? It should not be equal to r, because then that's an off by 1. Okay, well, look. So I got away with an off by 1 error. I think I was just rushing it at this point, hoping, even though it turns out that I didn't have any chance at the leaderboard, but hoping that I could get it in there. But I had multiple typos too, though, because I had like x and y instead of nx and y. So I don't even know where I guess xy is shadowed from here, because I don't really declare it. One of the things with Python that gets me a lot. But in any case, you just keep going. And you could kind of prove the bounds here, this n square things, and then I don't know what the dimension is, but let's say you have r times c, then at worst you can visit every cell, or you can visit r cells or c cells or r plus c cells, whatever is max, or max of r plus, or max of r comma c cells, because then you're guaranteed to get it off the board on one dimension and the other. So that means that this makes it n squared times max of r, or r plus c, I guess is the way to say it. And so not that bad, given that the constraints are not that high. Can I do better? Can I easily do better? I don't know, honestly, because the thing is that you want to keep it in, and then you have the dedupe. The dedupe is a little bit tricky. Like maybe you can say that, like I don't even know if this is true, but maybe you could do a sweep line thing where you calculate some stuff based off the GCD of every 2 points or something. But that is just crazy talk if you ask me. I don't think that's a real solution. I mean, you could do it, but I'm not sure that is even faster. But yeah, but I think that's all I have for this one. Let me know what you think, and this is my final result. Oh, I have to say bye bye to this other thing. How do I say bye bye to this other thing? But yeah, stats, leaderboard. So this is my final result. I think it's okay. I mean, I just didn't read it correctly, or I didn't read fast enough. I don't know, something. Maybe I'm just tired. I'm gonna blame it on that. But that's all I have for today. Let me know what you think. Thanks for watching. Yeah, I'll do this again tomorrow, ideally. So I mean, as a computer scientist or programmer or whatever, you always think about the edge cases. I don't want to promise 100% I'll be here tomorrow, but I should be. So yeah. You never know what happens. I could get hit by a car. So stay good, stay healthy, do good mental health. I'll see you all later and take care. Bye bye.